In this video, we're going to introduce the concept of correlation. And when we're talking about correlation, we're talking about data sets that are in the form of ordered pairs. And so we're going to be looking at ordered pairs, the x comma y, for bivariate data. And so in these, for correlation and regression lines, we're going to be looking at data in which we have an x and a y for the same value, same point. These are two values that come from the same information, such as a person's height and weight, or their age and weight, things of that nature, things that are related to a single person or a single object, and they can be identified as ordered pairs. And so a way to visualize this data is scatter plots, and each individual in the data set contributes an ordered pair, the x comma y. And we plot these on a set of axes, and we just plot the points. We don't connect them. That's why it's called a scatter plot, is because we literally just plot the points. So for instance, here is a set of axes. Remember that your y and your x. And so let's say that we have the points 3, 2, 5, 7, 2, 1, and so forth. And I'm going to put up here some grid lines so that we can kind of see a little bit better. And so the point 3, 2 is going to be, I'm going to come over 3 on my x, 1, 2, 3, and go up on my y, 2. So I'm going to put a point right here. This is 3, 2. Now for 5, 7, I go right 5, 1, 2, 3, 4, 5, and then I go up 7, 1, 2, 3, 4, 5, 6, 7. And I put a point. Same thing for 2, 1. I go over 2 and up 1, and there's my point. And so we've created a scatter plot with these 3 points. I've just plotted those points. Remember, the first number always tells me how far right I'm going. The second number tells me how far up or down I'm going while I'm looking at my graph. So now then, if I take my grid lines back off so that I can look at my other information and look at some different associations that we have. We have different types of associations. If you look at this first one, and I'm looking at this is my y and this is my x, and so if you look at these points that I've plotted here, notice they're fairly close together, and they're all increasing from left to right. What we call that is, if you notice, you can kind of make out what we would consider a line. And so, again, it's increasing as we go from left to right. So this is going to be a positive linear association because it is increasing from left to right. That makes it positive, and then it looks almost like a straight line. Over here, we have an association in which it is decreasing from left to right, so that would make it negative. And it does look almost linear, so we're going to say a negative linear association. Now this one right here, I can't make out a whole lot. I can kind of make out a little bit of a line, but there's a lot above it, a lot below it, and everything. And so this one would actually be considered a weak association. We still have a little bit of linear, so we could even call it a weak linear association and everything, but it's still very weak because we have a lot that are out on the outside. Now for the next one, if you notice, it's not necessarily a straight line. It is still increasing as we read from left to right, so that's still going to be a positive, but it's not a straight line. If it was a straight line, it would go right through here, but notice there's a little bit of a curve to it. So this one's just a positive nonlinear because it's not a straight line. On this last one, we look at it, and it's going down, decreasing from left to right. So that's going to make it a negative association. And it's not linear because it doesn't make a straight line, so this is a negative non-linear association. And so where we're looking at these, a positive association is whenever we have large values of one variable associated with large values of another variable. So again, the smaller values associate with each other and the larger values associate with each other. The opposite is true whenever we're looking at negative. So if the large values of one variable are associated with the small values of another, that's what makes it decrease. And it's that linear relationship if it tends to cluster around a straight line. So we want to measure the strength of this linear relationship. And the way we measure the strength of a linear, and this is only for linear relationships, is what we call the correlation coefficient. The formula for correlation coefficient is R, and then we have 1 over n minus 1. N is just the number of pairs that we have, or the number of points, the ordered pairs that we have. And then we have the sum of our x values minus their mean divided by their standard deviation times the y value minus its mean divided by the standard deviation for y. So what we're going to do is we're going to take each x value and subtract the mean for the x values from it and divide by the standard deviation. We're going to do the same thing with the y values. We're going to take y minus its mean and then divide it by its standard deviation. We'll multiply those. After we have multiplied them, we will add them all up. And then we'll divide by n minus 1. For R must be between a positive 1 and a negative 1. It can equal a positive 1 and it can equal a negative 1. It just has to be between those. So if you've done some calculations or something and you get a 2.3 or a negative 4.8 or anything like that, you're going to know that you've done something incorrectly. Your R must be a decimal. It can be positive or negative though. So it's not like it has to be one or the other. It can be either one. And correlation coefficients, it doesn't matter what units. So in other words, the units of your x can be different from the units of your y. They're still calculated the exact same way. We don't worry about the units or anything for the R. So let's look at an example. We have a golf pro that wants to investigate the relationship between the club head speed of a golf club, in which it's measured miles per hour, and the distance in yards that the ball will travel. We want to determine the linear correlation between the club head speed and the distance. Well, this particular problem has provided us with the mean for each. So it tells us that the mean club head speed is 101.88 with a standard deviation of 2.295, and the mean distance is 266.75 with a standard deviation of 7.741. And so I've already started this table, and so if we state that the club head speed is your x and the distance is your y, that means that we're going to take each of our x values, so the 100, minus 101.88, divided by its standard deviation of 2.295. So I'm going to take 100 minus 101.88, which would actually give me a negative 1.88, divided by 2.295. And that's going to give me a negative 0.81917. And I'm going to do this all the way down. So I'm going to take 102 minus 101.88, and then take that number and divide it by 2.295, and I get a positive 0.05229. I'm trying not to round any of these values any more than I have to, because we don't want to round until the very end. And our correlation coefficient, we're going to round to 3 decimal places wherever we finish. So I'm going to continue filling in the table. I would suggest that you attempt to do some of these on your own and see if you're coming up with approximately the same numbers. And that way we can compare as far as what our values are. So I've completed this column for our club head value minus its mean divided by its standard deviation. Then I'm going to move over to the y values, the distance, and I'm going to take each distance minus their mean, which is 266.75, and divide it by 7.741. So my first one is going to be 1.25953, because I took 257 minus the 266.75, and then I divided that by 7.741. And I'm going to continue this all the way down. So why don't you try some of these while I finish filling in the table. Okay, so I've completed filling in this column. What we're going to do at this point is we're going to take this negative 0.81917 and we're going to multiply it by the negative 1.25953. So we're going to take these two and multiply, and I get a 1.03177. Then I take the 0.05229, multiply that by the negative 0.35525, and I get a negative 0.01858. And I'm going to continue this all the way down, multiplying this third column times the fourth column to get my last column. Okay, I have finished filling in this last column where I've taken each of these calculated values and multiplied by its partner calculated value, and I've come up with this last column. Now to find my correlation coefficient, I'm going to add all of these up. And so I'm going to take 1.03177 plus a negative 0.01858 plus a 0.45706 and all the way down, and I'm going to get a 6.57169 as my total here. Now R is 1 over n minus 1 times the sum of this value that I just calculated. So n, I have 1, 2, 3, 4, 5, 6, 7, 8 pairs here. So that's going to be 8 minus 1 times 6.57169. And so I get R is equal to 1 over 7 times a 6.57169. And whenever I multiply that out and round to 3 decimals, so let me make a note, R round to 3 decimals, I'm going to get 0.939. And I want to look at that. Notice that it is positive. which means the higher values of x have higher values of y. The lower values of x tend to have the lower values of y. And it's very close to 1. So this actually has a strong positive linear association. Because looking at its R value, which is what we consider when we're talking about correlation and its coefficient. So where we're just talking about the R, if R is positive, like it was on the previous one, the two variables have a positive linear association. If R is negative, it's going to have a negative association. The closer to 0, the weaker the association is. So it doesn't matter if it's a negative 0.03, so negative 0.03. This is going to be a very weak association because it's close to that 0. Think of a number line, and we put 0 here, and we put a negative 1 here, and a positive 1 here. On this end is going to be the strong negative associations. On this end is going to be the strong positive associations. Here in the middle is where they're going to be weak. So it can be on the negative side or the positive side, but they're going to be weak here in the center. As far as linear associations, they may be nonlinear associations, but we don't know that for sure. And then, like I was just saying, the closer to the positive one or the negative one means the stronger that it is. So try calculating some of the correlation coefficients, and if you have questions or run into some trouble, let me know. Be careful with your calculations on the standard deviation and means. You have to be very careful with those. So, like I said, let me know if you have questions.